Hello everyone. Today we're going to talk about typecasting in Swift. And as you've known so far, the type of data in Swift is very, very important. So we've worked with things like ints and doubles and strings, and each of those has an associated type. And you can do certain things with types. So for example, you can add two ints together. You can print strings. Of course, you can print other things as well. The point is specific types have specific behaviors. So we're going to talk a little bit today about how to turn one type into another, and that's called casting. So before we do that, let me give you a little review of the setup here. So one of the things we haven't talked a lot about is classes. We've worked mainly with structs. And there's really two important differences between classes and structs. And you can see I've written a class here. The first difference is that a struct will create a member-wise initializer if you don't have one. So you don't necessarily need an init method. Whereas for a class, you have to write it yourself. The other thing that you can do with a class is you can make subclasses. So for example, let's look at our class person here. A person is a very generalized idea of a person, and this person has a name. I have an init method here that takes a name as a parameter and assigns it to the property name. However, you can have more specific types of person. So for example, I have another class, doctor, and you can see I have a colon here and then person, which indicates that a doctor is a subclass of a person. So it's a more specific example of a person. And I don't have anything inside these braces, though I could put specific behaviors and functions and properties of doctors that would set them apart from other people. Same thing for a lawyer. A lawyer is also a more specific type of person. And a teacher is a more specific type of person. So a doctor, what's called, inherits the properties of its superclass or the person. So I don't have to write the name part again because the doctor automatically gets it. And the same thing with a lawyer and a teacher. So they automatically get the initializer and the name property. That's really all you need to know about classes for right now. We're just setting this up so that we can look at typecasting. So I've written some subclasses. Now I've written a few different types of methods. So for example, I have a defended by method that takes a lawyer as a parameter. And again, notice it takes a specific type, right? That lawyer is a specific type. I also have a function healed by, and healed by a doctor. That requires a specific type. And same thing with taught. Taught requires a teacher parameter, and they each print out different messages. So then I just create an instance of each one of these. So I have a lawyer equals a lawyer named Alice, a doctor equals a doctor named Belinda, and a teacher equals a teacher named Catherine. And then I've put those three people into an array. So again, normally what you see with arrays is they all have to have a specific type, like an array of strings or an array of ints or an array of doubles. In this case, let's check the type of this. So I'm going to go ahead and hold the Option key down, and I'm going to click on people, and you can see the type is person. It automatically defaults to the more general class type. Okay, so the type is person because a lawyer is a person, a doctor is a person, and a teacher is a person. Okay? Since they all can't be lawyers or doctors or people, it goes to the more generalized type. Okay, so what if I want to well, let's say that I want to pick a random person for some reason. Maybe it's jury duty or something. So I'm going to go ahead and get a random person. So I'll say let person equals, well, I guess I got to make a function get random person, huh? Let's do that. Let's do function get random person, and it's going to return a person. Well, if I got a lawyer, I should return a lawyer. If I got a doctor, I should return a doctor. But I can't do that. A function can't return multiple types, so I kind of have to default back to that general type and say, okay, I will return a person. And then what I'm going to do is I'm going to use a special method of arrays called getRandomElement, or random element. So I'm going to return people, and I'll do random element. Now, with random element returns an optional. So it won't, just in case the array is empty, it won't let you return a nil value. So you have to say, if it's empty, do return something else. So I'm going to go ahead and put 2 question marks, which basically means if I can return a value, go ahead and do that. Otherwise, I'm going to return, I don't know, a teacher named Brian. So all this line means is if I can return a person from my array, go ahead and return that person. If for some reason it's empty, return a generic teacher named Brian. And so it'll always return some value and it will not crash, which is, again, a great use of optionals. So now let's go ahead and do person equals get random person. So now, oops, I forgot to put, let's do let. And if I look at the type of person, well, it's definitely a person. But if I want to do one of these specific methods, I have to what's called typecast it. I have to cast it as a more specific type. So let's see what that looks like. Well, let's say, for example, I wanted to do taught by person. That should give me an error, and it does, because it says I can't convert the value of person, a generic person, to the teacher, right? The taught method or taught function expects a teacher. It doesn't want a generic person. So I have to say, if it happens to be a teacher, then do the teacher method. If it's a lawyer, do the lawyer method. And I can do that using the if-let syntax and something called downcasting. Downcasting means make it a more specific type. So let's see what that looks like. So if I say if-let, I'll say if it's a lawyer, equal person, and here's where the downcasting comes in. As, and I do as question mark, right? So I'm saying if I can cast that person as a lawyer, right, then go ahead and say, I guess it's defended by law. So the person is my lawyer. Can't spell it, right? So this basically says, if let law, and law is just a variable I made up to represent my lawyer person. So if I can let lawyer equal the person as a lawyer. So if I can cast the person I just got back as a lawyer, so if it's a lawyer, I'll set that person equal to law. Then I can call the defended by method knowing that this law is of type lawyer. And I can do the same thing for the other two. So I can do else if let, I'll say doc equal person as doctor. Then healed by doc. So this basically says if I can let this variable doc equal a person cast as a doctor. So if I can make this, if this person is a doctor, of type doctor, then go ahead and call the healed by method. And then finally, else if let teach. And again, I can make these variables anything I want. I'm making them make sense in this context. So person as teacher, taught by teach. So in each case, I'm downcasting, or I'm using this as. If I can make it that type, then go ahead and call that. In this way, no matter what person I get back from this random person call, it will call the right method on that. So let's go ahead and run this just to see what it looks like. So I must have gotten back the doctor. Right? So the doctor was Belinda, and it says Belinda gives you some medicine. Okay? It is possible to do the as with the question or the exclamation point, but that means you better know for sure that you're going to get that back. In this case, we wouldn't use that because we don't know. It's random. We don't know what we're going to get back, so we can't use the as exclamation point. But if you get to a point in your code where you absolutely positively know it's going to be that, then you can use the exclamation point. So one last thing to talk about is we kind of talked about arrays having a mixed number of types. So for example, in our other array, in the array here for people, we had a lawyer and a doctor and a teacher, but they were all types of person. So we could use the type of that array as person, uh, and I could hold subclasses of that person. Well, what we haven't seen is, let's do an array. Let's say array, let's say values equals, and I'm going to put some numbers in here, 3.4, 5. So 3.4 is a double. 5 is an integer. I might have pi, and I might have, well, let's just do those right now. So I have a mix of doubles, ints, and strings, and it doesn't like that because it thinks variables should be of one type. So if I am going to mix it, Swift provides the special type called any. So I can make the values of type any. And I can make sure to spell it right. And now I don't get that error because I'm saying it can be any. So I can put any type I want into that array as long as I define the type being any. But then if I try to get information back out of that array and do stuff with it, I have to cast it to that particular type. So for example, if I wanted to add another number to this double, I would have to cast that value as a double. So for example, that might look like this. So I can say if let number, and again, that's just the variable I'm making up, equal values 0 as a double. So if I can cast this number as a double, then I'll print, let's do, how about 6.7 plus number. So if I can make this values, the first number in values, right? Value 0 is the first item. If I can cast it as a double, I'll save that into this variable number. And then I'm just going to print those two together. So if I run that, I get 10.1. So again, I'm casting one type of a more specific type, or sorry, a more general type to a more specific type. Okay? That's typecasting. Again, I hope this makes sense, but if not, please go ahead and read the information in